first of all, let's take a look at oxygen. And if you look at oxygen, it has a normal electron configuration. So here's oxygen. It would be 1s2, 2s2, 2p, and then you'd count over 1, 2, 3, 4. So 2p4. Okay, now oxygen is a nonmetal, and nonmetals tend to gain electrons to become more stable. So oxygen, if you look, it's going to gain electrons until it has an electron configuration that is the same as a noble gas. So oxygen's right here, so the closest noble gas to oxygen is neon. It's going to have to gain 2 electrons. So now oxygen usually forms an oxygen 2- ion. And the reason is because it gains 2 electrons. So what you would do to write the electron configuration, you would write it just like oxygen, 1s2, 2s2, but at the end, okay, we have to add 2 more electrons, so instead of being 2p4, it's going to be 2p1, 2. And so it would be oxygen 2, end up being oxygen 2p6. Now, what we can say is we can say that oxygen 2-, so the oxygen ion, which is called oxide, and neon, we can say that they're isoelectronic, which is kind of a big word that means that they have the same electron configuration. So oxygen 2- has the same electron configuration as neon. Okay? Let's try another one here. Alright? So let's try one that's a metal. So let's try calcium, and we know that calcium's in group 2A, and so calcium is usually going to form a 2+ ion. So first of all, let's write the electron configuration for calcium. So we would write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Alright, now calcium is a metal. And I always like to say that metals are losers because they lose electrons, okay? And so calcium is going to lose the amount of electrons until it becomes like a noble gas. Okay, so we could look, we just count backwards from calcium. Okay, so we count backwards and go 1, 2. So calcium is going to have an electron configuration just like argon when it becomes an ion. So what you would do for calcium is you would write 1s2, 2s2, 2p6, 3s2, 3p6. Okay, now normally calcium is 4s2, so we'll write it right there, but it's going to lose the number of electrons until it becomes like a noble gas. So it's going to lose 1, 2, and then it's going to be like argon. So we have to get rid of the 4s2. Alright? So when we get rid of the 4s2, now we have calcium 2+, the ions, electron configuration, which is the same as the nearest noble gas, which is argon. Okay? You count 2 back. Okay? Let's try another one here. Alright, so here would be another one. Alright, so let's say that we picked one like nitrogen. Okay, so nitrogen, okay, we got to think about nitrogen because nitrogen could either, to become like a noble gas, it could gain 1, 2, 3 electrons, or it could lose 1, 2, 3, 4, 5. Okay, well, nitrogen's going to gain 3. Okay, and nonmetals, okay, gain electrons, so it's going to gain 3 and be like neon. So to do nitrogen 3-, okay, we can write it 1s2, okay, 2s2. Okay, now normally nitrogen would be 2p, 1, 2, 3, but it's going to gain 3, so we got to add 3 more electrons. So it'll be 2p6. Okay, so anyway, to check your work, does nitrogen 3- or nitride, does it have the same electron configuration as the nearest noble gas? Yes, it does. Okay? Alright, let's do another one here. Now, sometimes when you get down here into these transition metals, things can get a little harder. Okay, so let's try titanium. Okay, now I'm just going to write it the shortcut way. So titanium, okay, that's not an ion, is argon 4s2 3d2. Now, titanium when it becomes an ion, a lot of times it becomes a 2+ ion. Okay, now here's the tricky part about these transition metals. Okay, so when they become ions, what you need to do is first take away the highest numbered energy level electrons first. We have to take away 2 electrons. Okay, and so 4 is a higher number than 3. Okay, even though the 3D fills after the 4s, but the 4 is a higher one. So we're going to take away those 2 electrons first. And so titanium 2+ is actually argon 3D2. Okay, let's try one more of those transition metals. All right, so let's do let's just do nickel. All right. So nickel, if we did it the shortcut way, it would be argon. Then it would be 4s2 3d8. Okay, well nickel, let's just say that we have a nickel 3+ this time. Okay, I don't even know if nickel becomes a 3+, but let's just say it does, okay? Alright, so anyway, if we're going to take away 3 electrons from nickel, okay, we're going to start with argon. Okay, now we got 4s2 3d8. So it's always going to take away the highest numbered energy level ones first. And so we're going to get rid of the 4s2. So now we've got 3d, but we're not going to write 8 because we've got to take away one more. So it'd be 3d7. Okay? So that's kind of a beginning. I know there are many exceptions when you get to these transition metals, but just try to always take away the higher numbered energy level electrons first. Then you can work on taking away the Ds if you have to take away more. Okay, with things that are in the main group elements, okay, their electron configuration when they become ions need to match a noble gas. All right, that's it.